Hi everyone, and welcome back to the Offsite channel. In today's short, we're going to be speaking about load paths, and Chris has put together a small presentation for us.
Thanks, Greg. So here in the U.S., we have some common practices that require a lot of communication. So, and today, what I'm going to talk a little bit about is load path and how important it is that we communicate in order to get it done properly. So that being said, here at the Offsite channel, we're trying to provide some education and just let you all know how important it is that offsite construction be considered. Some of these things just get overlooked in the design process and the build process.
Right. Yeah, no, this will be useful for people that don't fully understand how the loads transfer down the building, ultimately to the foundations. So should be quite interesting.
So first of all, here we got an example of a common load path, right? We got to recognize it's continuous. Regardless of what happens up top, it's got to go all the way down to the foundation, and we have to transfer all of that load down to the foundation. This happens generally with the connections. In some regions, most regions also use OSB, but we also have to consider how this feasibility transfers as a common load example here on a residential construction type design shell.
Yeah.
We also got to consider how to resist forces of uplift and how many different types of uplift resistance there is. Most common is use of metal connectors, but there are times where threaded rods are used to transfer the load all the way down from the top plate down to the foundation.
These are both at, obviously, at the sole plate and the mid floor, aren't they, Chris?
Yes, right. And it's important that we understand that just because we put an uplift connector at the top of the building, unless it's shored up down at the floor level, down at the bottom plate, down at the concrete level, it's useless. I mean, it really has to go all the way through in order to make maximum value reach. So next point to consider is in relation to how do we do this in the construction model? You know, the model that most of the softwares that we use today have this ability, but we're not using it. Why not? Why can't we utilize the model to spec these things? A lot of it has to do with intellectual property rights. Some of the metal connectors, the software companies and the metal connectors just haven't talked enough. The communication hasn't been given the ally mentality to allow all of those values and that intellectual property to exchange hands. And this is really where offsite construction can play a huge benefactor. You know, just because we call it out doesn't mean it's actually happening.
Absolutely.
So that being said, we got to communicate, folks. I mean, there are times where special connections are required. I mean, how many times as a truss designer have I designed a truss that's got a 6,000 pound uplift? You know, and making that happen and transferring that all the way down to the foundation on some of these extreme type girder conditions, you know, that requires communication.
It can also be in high wind uplift as well, snow. If you get a weight one side of the building, it can give you uplift reactions on the opposite, or like high wind situations as you do have in Florida now and again.
But unless we plan this out at the design stage, the chances are the foundation, that 6,000 pound uplift was not considered. And we can put all of the connectors we want on it, but it has to transfer all the way down to the bottom. Otherwise we end up with stuff that looks like this, and nobody wants that. We have to transfer these load paths all the way down to the foundation. This requires communication. So thanks to the FEMA and NAHB for these graphics that we shared with you today. openly found on the website. You'd be shocked at the amount of information that you can find just by taking a look. So, are we considering load path? Offsite construction, it's hard to miss this if we're all using a similar model, right, Greg? What do you see over there on the other side of the pond?
So typically, it's the responsibility of the frame engineer that would look into the requirements for obviously the load paths and the metal work that we have. So you need to make sure that your window headers are correctly sized to take the incoming load. You need to make sure you're specifying the correct metal work for uplift and trusses right down at the foundation. And this is all dependent on the location as well. The engineer needs to look at where is it? Is it coastal? Is the building up a mountain? Is it urban? Obviously, coastal, you would have greater wind loads. So, and also the height of the building. That's another factor to look at as well. So yeah, there's many considerations, but typically over here, when a component manufacturer employs a frame engineer for the wall panels, that is who is responsible for engineering, essentially. I don't know what it's like over in the US, if that's the same, but that's the way it is over here.
It's similar. Typically, we have a project engineer that's responsible for speccing out all of those connectors, and then it goes through the building department and it's up to the building inspector. But over here in the States, a lot of that relies on the truss designer or the wall panel designer to catch these things, because sometimes these things aren't known.
Yeah, you need to make sure that typically the engineer's information won't be sent to site. It'll be the component manufacturer that details up their drawings, and so that you need to make sure that you have the connection details on the frame drawings, so the framers on site know what to put where and how to fix it.
Right. Some of these modern designs that we're seeing over here now with high parapets for that external reveal look, there's a tremendous amount of wind load. There's a lot of lateral resistance that's required, and as a designer, not only do I have to consider the gravity loads, but I also have to consider the horizontal loads.
Yeah, and also man loads as well, because someone could trip and fall and go against it. You have to consider man load as well. So there's many things we have to look out for. Be aware of when you're reviewing the information back from the engineer. If something doesn't look as you'd expect, just ask the question.
And don't be afraid to ask that question either, because you may be the last resort to correcting that problem. I mean, I can't tell you how many times I've worked on a multifamily job and gotten up to the roof and found that what was happening down below was bearing on plywood. There was nothing there. And if I don't catch that, whose fault is it? And nobody wants that. But
no,
at the end of the day, the methods that we're using need a look. If you continue to do what you've always done, you'll continue to get what you've always got.
Exactly.
And some of the off-site construction benefits, just a lot of these problems just go away if we have collaboration and BIM and IFC files and all the other opportunities that are out there for us to work together.
Yeah, a lot of the software suppliers, they have 3D showrooms, I think that's what they were called, where the contractor or the framer can be sent that and they can rotate it in 3D, have a proper look before they even go to part, So if they have any queries, then they can be done ahead of time rather than retrospectively, which is a complete nightmare if it is the case of this.
That's right. And the manufacturers here have the opportunity to generate more revenue by selling that extra steel somebody's selling it, right? All of those connectors, if it's part of the package, that's more opportunity for profit.
Absolutely. So next up, we are going to speak about is it panel stud spacing?
Yeah, next time we're going to talk a little bit about how to consider, with the same mentality in load paths, how do we factor this as it goes down, specifically on timber frame and multifamily type jobs, multi-story type jobs.
Yeah.
16 inches on center may become 8 inches on center, down from one level to the next. So are we considering these things?
Well, we'll come back next week with that one. I think just we do have another podcast scheduled in, and but we would like to give a little bit more content in between. So hope you enjoyed, everyone, and we'll see you on the next video.